In this concept, we're going to talk about properties of inequalities. And these properties we're going to talk about are essentially going to enable us to be more efficient at solving the inequalities. So this is the goal behind learning these properties. So do not think that, you don't have to memorize them. You just have to be familiar with them, because this is the main way you're going to be manipulating inequalities when attempting to solve them. Okay, let's look at the first property. So the first property is the addition property of inequalities. And what this property tells us is that if you have an inequality, if you have, any two numbers, right, A and B, for example, with A being greater than B, right, then if you add the same value to both sides, the inequality still holds, right? So here's an example. So if 5 greater than 2 is true, which it is true, right? In this case, 5 is greater than 2. 5 is always greater than 2. Then if I add 3 to both sides, for example, then the inequality is still true, right? Because 5 plus 3 becomes 8, 2 plus 3 becomes 5. So 8 is also greater than 5, so the inequality is still true, okay? So if if A is greater than B, then A plus C is greater than B plus C. The same if the inequality sign were reversed, right? If A is less than B, then again, if I add constant, the same constant to both sides, then the inequality sign is still the same way that it was. So if 3 is less than 8, which it always is, 3 is always less than 8, then 3 plus 5 is also less than 8 plus 5, right? So because here you get 8 and 13, right? So 8 is always less than 13. The second property of inequalities is the subtraction property, okay? And this is basically similar to the addition property, but here we subtract the same value from both sides, right? So if you have A greater than B, then A minus some constant C is still going to be greater than B minus that same constant C. Okay, here's an example. If 19 greater than 5 is true, right, which it is, 19 is greater than 5, again, then 19 minus 8 is greater than 5 minus 8, right, because then this becomes 11 is greater than minus 3. So it continues to be true. If A is less than B, again, if the inequality sign were the opposite, then A minus C is still less than B minus C. Okay, here's an example. If 3 less than 5 is true, which it is, then 3 minus 2 is still less than 5 minus 2, or 1 is less than 3, which is still true. Okay, another property of inequalities, and this one can seem a little tricky, but you just have to understand the gist of it and just keep it in mind. Multiplying by a negative number is a property for inequalities that requires that when you do multiply by the negative number, you actually flip the inequality sign, right? And that's why it may seem a little tricky, but you just have to keep that in mind. So if A is greater than B, then if you multiply both sides by the negative number, then you basically flip the inequality sign after having done the multiplication. Let's look at an example to see why that is. So if 6 is greater than 2, right, which it is true, 6 is greater than 2, then 6 times negative 2 is not greater than 2 times negative 2, it's less than 2 times negative 2. Why is that? Because, well, here the absolute value of 6 is 6, the absolute value of 2 is 2, right? So 6 is greater than 2, but then when you multiply by the negative number, the bigger absolute value becomes on, the bigger number, the bigger absolute value number becomes negated, becomes negative. And on the negative side, a bigger a bigger negative number is a number that has a lower absolute value. So, minus 1, for example, is greater than minus 9. Minus 1, the minus 9 has a bigger absolute value, which is 9, right? So this is the smaller negative number. Okay, here the same is true. So 6 times negative 2 gives us negative 12. 2 times negative 2 gives us negative 4. Right? So negative 12, now, you can't say negative 12 is greater than, negative 4. This is not true, right? Negative 12 is less than negative 4, right? So this is why when you multiply by negative numbers, you have to flip the inequality sign. Okay? Let's look at another example. So if 5 is less than 9, right? Then 5 times minus 3 is greater than 9 times minus 3. Why? Again, because when you multiply 5 times minus 3, you get minus 15, right? When you multiply 9 times minus 3, you get minus 27. And which of these is the greater number? Well, it is the minus 15, right? So I had to flip the sign from here to here, the inequality sign. Okay? Multiplying by a positive number, the inequality sign stays the same, okay? Because the absolute value, the relative absolute values are still the same. They haven't been flipped over. But there was no change in sign, so we don't have to flip to change the inequality sign. So here, let A and B be any numbers, and C is a positive number. So if A is greater than B, then A times C is still greater than B times C. Okay, here's an example. If 18 is greater than 3, then 18 times 2 is still greater than 3 times 2, right? So 36 is greater than 6, and that's also true. And again, if A is less than B, then AC is less than BC. Again, so 15 less than 13. Actually, no, this is a typo. So if 13 is greater than 15, right? Then 13 times 3 is less than 15 times 3. Okay? So 39 is less than 75. Okay? This was a typo. Okay? The next property is dividing by a positive number. And dividing by a positive number is very similar to multiplying by a positive number, in the sense that the inequality sign is not flipped. Okay, so if A is greater than B, then if I divide both sides by the same number, by the same positive number C, then A over C is still greater than B over C. Okay, here's an example. If 6 is greater than 4, which it is, then 6 divided by 2 is still greater than 4 divided by 2. Or 3 is greater than 2, which is true. Okay, if A is less than B, then A over C is less than B over C. Again, if 25 is less than 35, which it is, then 25 divided by 5 is less than, another typo, still less than 35 over 5, okay? So 25 divided by 5 is 5, 35 divided by 5 is 7, so 5 is less than 7, okay? And this is true. Dividing by a negative number is similar to multiplying by a negative number, okay? And it's very similar to multiplication by a negative number, in which the inequality sign is flipped, okay? So if A is greater than B, then if I divide by the same negative number C, then I flip the inequality sign. So if A is greater than B, then A over C is less than B over C, okay? Just like I have here. Here's an example. For 14 greater than 12, which is true, then 14 divided by negative 2 is less than 12 divided by negative 2. Why? Because 14 divided by negative 2 is negative 7, 12 divided by negative 2 is negative 6, and negative 7 is less than negative 6. Okay? So 14 is greater than negative 2, but negative 7 is less than negative 6. So again, dividing by a negative number necessitates flipping the inequality sign. If A is less than B, then A over C is greater than B over C. So, right, so 24, if so, here, if I have 36, if I have 24 and less than 36, right, then if I divide both of them by negative 6, then it becomes 24 over negative 6 is greater than 36 over negative 6. Okay, just like I have here, right? In which case I have 24 divided by negative 6 is negative 4, and then 36 divided by negative 6 is negative 6, right? Which is true. Okay, so I started from here, and then I went to here because of dividing by a negative number, right? So I flipped the inequality sign. Okay, this is it for this concept. See you in the next video.